Hey guys, let's keep going. On this video, we're going to learn about using the calculator. So let me go ahead and get here. All right, so we're going to start from here. Using a rejection region in a hypothesis test for a population mean using the calculator. All right, so in the example we looked at before, the State Education Department is considering introducing new initiatives to boost the reading level for fourth graders. The mean reading level of fourth graders in the state over the last 5 years was a Lexile reader measure of 800 L. A Lexile reading measure is a measure of complexity of the language. The developers of the new program claim their techniques will raise the mean reading level by more than 50 L. Okay. To assess the impact of their initiatives, the developers were given permission to implement their ideas in the classroom. At the end of the pilot study, a simple random sample of 1,000 fourth graders had a mean reading level of 856. It's assumed that the population standard deviation is 98. Calculate the p-value for this hypothesis test. So what we're going to do is we're going to make our hypotheses. So we did that before and we found that the alternative, the mean was greater than 850, and for the null, the mean was less than or equal to 850. Okay, we know this is a right-tailed test. Why do we know it's right? Because for that alternative, it's greater. The mean is greater than 850. That's the easiest way to do that. So in terms of the sampling distribution, we know we have 1,000 scores that we looked at for different kids. So we're going to, the p-value for getting a situation is the probability of getting a sample mean greater than or equal to 856, written as the p-value equals p, where the sample mean is greater than or equal to 856. So go into your calculator. So go do second bar, which is variable, and go to distribution. You want to go to Q, okay? So this is what you're going to enter. So we're going to enter it like this. What was 856 again? 856 was the value of the the amount you needed to look at. So you're going to do 1 second, comma, 99, comma. So then you're going to do 850, which is the mean, which is the population mean. And then you're going to do 98 divided by the square root of 1,000. And then you do comma. Okay? And then you hit enter. So you should get 0.0264. Right? So that's your p-value. Okay? This is how it looked entered. It looks kind of crazy, but it's okay. Alright. So note that by solving the p-value one step, we eliminated any rounding rules. This is very, very similar to what you did in Chapter 6. So don't get confused and know when to use the right formulas, because Chapter 10 is very different from Chapter 6. You're using the normal CDF again, and the reason we can do that is because of that Z statistic. The only thing that changed is the actual equation itself. Okay? All right. I'm going to stop here and